Let's take a look at a motion diagram for a very particular type of motion. We have somebody riding a bicycle, starting from rest, speeding up, and then moving at a constant speed. Let's take a look. So let's build up a motion diagram for the bicyclist. The bicyclist starts at rest, and then she starts moving forward. So her speed is increasing. And just like we did in the last chapter, we're going to put down dots to mark her position at uniform intervals of time. So the different dots show us where she was, and we can see the distance between the dots is getting larger. And just as we did previously, we'll add velocity vectors between the two dots. And that will show us that as she's moving faster, the distance between the dots is getting bigger, her velocity is increasing, so the velocity vectors are getting bigger. But there's another way that we could represent this motion. A motion diagram is a great tool, but in this chapter, we're going to look at other representations. And one representation we want to look at is a graphical representation. So for the motion that you just saw, let's look at how we would draw a graph. For this motion, let's draw a velocity versus time graph. A velocity versus time graph means this. Time is on the horizontal axis. Velocity is on the vertical axis. She's moving to the right, so her velocity is always positive. So here's what happens. Her velocity starts at 0. It steadily increases for some interval of time, and then at some point, her velocity is steady, and she continues at a constant velocity. So this is what a velocity versus time graph looks like for this motion. And these graphs will be a very powerful way for us to analyze motion. They'll be a very useful tool as we start to solve problems. Now we want to look at a different case, and we're going to give you a chance to work out what a velocity versus time graph will look like. We'll look at a cyclist again, but in this case the motion is slightly different. So we're going to show you the motion of a cyclist. We'll show you the motion diagram, and we'll ask you to think about what the graph would look like. So here's our cyclist again, but she's starting moving at a constant speed. And then at some point she puts on the brakes, her speed decreases, and she slows to a stop. We've drawn up the motion diagram as we've done previously, but now we want you to draw a velocity versus time graph for this motion. What should it look like? We'll give you some choices. The velocity versus time graph is a representation of her motion. And think about this. She started out moving with a positive velocity. And so the velocity versus time graph is just moving horizontally. The velocity is steady as time goes on. Then at some point the velocity starts to decrease. And so at that point, the velocity versus time graph slopes downward and goes and hits the axis. Because at that point, at that time, her velocity has gone to 0.